Hello everyone, I think I'm live right now. If you are able to hear my voice or is there any difficulty with the same, please do let me know so that I can handle that thing out right now. Are you all able to hear my voice very clearly? If not, please do let me know that I can handle that out. Hello, and my name is Shaurya Sinha, and I'm a part of Shape AI, and I will be taking today's class. Yeah. So if everyone is able to hear my voice or if there's some difficulty, please do let me know. We'll be starting in 5 minutes, guys. So it's great to have you all on board right now with me. If you have any questions or queries, please do let me know. We'll be starting in 5 minutes. And yeah, please do let me know if I can help you out in any way. If you are not able to hear my voice or if there's some problem with my voice, please do let me know. Okay, so anybody who is live right now and is attending this session on how to use data analysis and machine learning on the data set, that is Titanic data set, please just write hey in the live chat so that I can know you personally. Uh, Anyone who is live right now, please write a hey in the chat, live chat. Yeah. We'll be starting in 5 to 10 minutes, guys. Today's lesson will be all theoretical. We'll be handling all the theory that is behind the entire session of neural networks and artificial neural networks as well. In tomorrow's session, will be handled by Parag Mittal from Microsoft. He will be teaching you hands-on machine learning in the tomorrow's session. You will be provided with all the workbooks that we are using right now so that you can also use that as well. Also, people who are currently from the Python for data science group or some other group, please do let me know that as well so that I can know exactly how many new people have joined us. Anyone who is new to Shape AI or has the first time has come to our particular YouTube channel or our particular workshop, please do let me know. Yeah. Hi Jay. Hi Saurabh. Um, I hope you are all doing well during this pandemic session and enjoying the vacation as well. I hope that in some areas there is some vacation of 5 days, I guess, for the Puja. That's great. So we'll be starting in 5 more minutes, guys. Anyone who is joining us for the first time, okay, the first time is joining us for any workshop or any session, do write a hey or a hi in the live chat so that I can know. Okay, anyone who is joining us for the first session ever with Shape AI for a live workshop, please write a hey or a hi on the chat section so that I can know. In today's session, again, I will be dealing with the theoretical section of neural networks and many other things, ANNs, neural networks, TensorFlow, all the conceptual things that is working behind them. And in tomorrow's session will be taken up by Parag Mittal, who will be from Microsoft. He will be taking your hands-on particular thing as well. Okay. So anyone who is joining us live will be starting in 5 minutes. Be waiting for everyone to join us. I guess the time given was 6:30. So we'll be waiting up till 6:45 and then we'll be starting with today's session. Okay. Uh, so if anyone has any problem or any doubts, please do let me know, guys. If anyone has any doubts or any problems, please do let me know, guys, so that I can handle that right now. So the people who are coming to us for the first time, can you all tell me from which college are you from so that I can know that as well? Everyone who is coming for the first time attending any live session by Shape AI, just write down in the comment section from which college are you from. If there's any problem with my voice, you're not able to hear my voice clearly, or there's some other problem, do let me know that as well so that I can help you out. That's great, Saurav and Anamya. It's great to have you all with us, joining us right now. Okay, this will be amazing, guys. The this session would be amazing. We'll be dealing with a lot. We'll be also looking into to understand the webinar. What are the prerequisites? The prerequisites is just basic mathematics that you must have studied in your 11th and 12th standard. If you were from like if you have ever studied from the NCERT. Okay, so it's very important that you are studying from an NCERT in the 11th and 12th standard. Otherwise, everything you will be able to understand everything because we're starting from the very beginning, very easy things, and we'll be slowly and steadily giving you a great insight upon everything. Okay, so don't worry, guys. It will be an amazing experience. We'll be starting from 6:45. Okay, 6:40. Sorry, 6:40. We'll be starting the session from 6:40. We'll be waiting for everyone to join us. Okay, so let me give a brief introduction about myself. I am Shaurya Sinha, and I'm currently pursuing like I'm the CEO of ShapeAI as well, and I have already taken a post like data analyst in Geo and all those things. My friend Parag Mittal is from Microsoft. He is a software development engineer. He's the co-founder and CXO of ShapeAI, and we'll be taking your session for the next 2 days on neural networks and ANNs. You will be dealing with a hands-on project of Titanic dataset. Okay, you must have heard about the hiccup that had happened. That is the Titanic event. Okay, so we'll be predicting if a particular person lives or die. Okay, the video is stuck. Okay, give me a second, guys. I will just figure it out. What happened? Okay, there's a problem with my video. I just wait for 1 second and I will handle it. Give me just 1 minute and I will handle it shortly. Give me 2 seconds, guys. I hope now my like video is clear right now. If there's any problem with the video, like I know the video is a bit pandemic. Just give me a second, guys. Yeah, I guess this is perfect, guys. If you are still having some problem with the webcam, please do let me know. I hope my the entire video and audio is perfect right now. If there's some other problem, please do let me know, guys. Okay? Yeah. So welcome to Shape AI, everyone. And in today's session, we will be dealing with the Titanic. Like, we will be dealing with the entire theoretical knowledge that you require to attend the tomorrow's hands-on class. Okay. One of the things that we always, the motive behind Shape AI is we always tell people that only skills are not important. Skills and experience are the two things that will get you placed and learning any new technology, you are learning that to get placed in a good company just like us, like in an MNC, in a big MNC with a good package. So the idea behind Shape AI is the same thing. We are here so that we can ensure that you get placed in a good college. So let's start, guys, with today's session. Okay, and I hope you enjoy today's session. If you have any questions, any problems, we'll be handling it at the end of today's session. Okay, guys. So this is the first webinar, okay, of the 2 days workshop on neural networks. So getting started with neural networks. Neural networks, so try to understand this. Like how did we came upon the idea behind neural networks? Today, the leading thing in AI is using neurons, artificial neurons, and creating different architectures that can be used to make different products, from your Netflix recommendation to your smart driving cars or your Alexa, Google, and many other things. Use machine learning everywhere, even in cloud computing. If anyone is interested in cloud computing, there's a concept of load balancing. Okay, all the big companies from GCP, that is Google Cloud Platform, to AWS, Amazon Web Services, to even Azure, use machine learning to handle all these type of stuffs as well. So the main core idea behind neural, like artificial intelligence, is this neural networks. That is the base foundation upon which the major deep neural nets and all these architectures are being made. So how did neurons came into being? For example, let's take the example of an aeroplane. Okay, so think of an aeroplane as in, for example, like how did an aeroplane came into being? You looked, Wright brothers or some other person, Da Vinci, looked at a particular bird. Okay, looked at a particular bird and came into a realization that I want to fly like it. Okay, I want to fly like a bird, and thus came the invention of an aeroplane. Now, the aeroplane does not has to flap its wings like a bird. You have never seen an aeroplane that is flapping its wings to like fly. The core ideology, like the inspiration, was gotten from the bird. Like many of the components like aerodynamicity and all these things were taken from the bird, but regardless, we don't have flapping wings, so we don't have to copy exactly from the nature to create an artificial being. So similarly, when the scientists came upon with like creating an intelligent life form or an intelligent machine, okay, they looked at human beings, okay, one of the most intelligent beings on this planet. They looked at how our brains function. So in our brains there are a lot of neurons. Okay, like as you can see here, this is a particular neuron inside our brain. Okay, now these neurons have like they have particular dendrites, they have axon, and they have like from where the signal transmits. Okay, so this is a neuron that is present in our brain. So what these researchers did was tried to implement some ideas of neuroscience to computers. Okay, in 1940s they tried to implement some of the ideas, like taking it directly, the neurons, they taken up how the neurons work directly and tried to implement it into the like computers, and they called these like the artificial neural neurons that they created, they also called it neurons. Okay, they called it neurons. Now at present there's a lot of debate because the as time progress, like I've already said, you don't have aeroplanes that are flapping their wings. Okay, we have aeroplanes that work different, but they have the same ideology to help us fly. So similarly, the current neurons, artificial neurons, are a little bit different from what the researchers, that is Mitz and Pitbull and all those things, all those researchers discussed in 1940. Now the current new there's a current like debate going on to renaming these neurons as artificial units. Okay, to rename these neurons as artificial neurons. So this is the current trend. We will be calling all these neurons, artificial neurons, as units or artificial neurons in the coming session, so that if anywhere I'm using these two type of words, you're easily able to understand what I'm trying to refer to. Now where are these neural networks like commonly used? So neural networks are commonly used in image, okay, image search service. For example, you can reverse search an image in Google. If you have ever tried that, it's great. You can go ahead and try it. You can just put an image as a search parameter, and Google will respond with what is that image, or like similar images to that particular image as well. Self-driving cars, recommendation systems, self-driving cars, Tesla, recommendations, for example, Netflix, Prime videos that you must be using. Okay, fraud detection in all the different financial companies, or even Amazon and Flipkart also have their fraud detection services available. They're also used in such a voice recognition, for example, Siri, Google, Alexa, Google Assistant, all those things. Natural language processing also a part of these. They are able to understand what you are trying to say. Okay, that is called as natural language processing. Again, there's so much more to neural networks. We'll get started with the neural networks. So like coming to this particular structure, as you can see, this is a particular neuron that is present in the human brain. So what happens is, this particular neuron, okay, so just wait a second. This particular neuron gets some type of input. Okay, it gets some type of electrical input, and then it transmits it through the nucleus. So this is the nucleus, guys. This is where all the computation happens. All the like electrical signals that were passed now are getting like they're decrypted. Okay, what was the information that was hidden in that particular signal is being retrieved in the neuron itself. It is then transmitted further, like whatever computation that needs to be done has been done. It transmits further, and then it gets released again to the next neuron. Now the next neuron will be taking it as an input again, and again the same process will repeat. It will take it in, it will do some computation, it will move forward, and like so at the end, maybe it may be possible that there's a particular muscle that is present. Okay, here for example, a particular muscle is present, and this signal then tells the muscle that okay, you have to contract or expand accordingly. Whatever the signal has been decrypted, whatever the information has been achieved via this particular neuron, it is then transmitted to the muscle, telling the giving it some instructions about what to do right now. Okay, moving further, so exactly, again, these all steps are being repeated. Neurons are connected to and receive electrical signals from other neurons. As we have already said that neurons are connected to other neurons as well. Okay, and they receive and transmit signals. Moving forward, neurons process input signals and can be activated. So the nucleus of the neurons processes the entire input signals, and figures out whether the attachment, for example, the missile, needs to be activated in some particular form or not. Okay, so this is how a biological neural network works. Okay, so the question arises is, can we take the biological idea of how humans learn and apply it to machine as well? Okay, so how does a human learn? So, okay, so for example, let's take a small baby. Okay, this is small baby, and there's a fire around him. Okay, there's a fire or a hot object. Okay, let's take a hot object. Now what happens is, this baby will touch this particular hot object and scream. Okay, so this baby will scream that like he or she got hurt or something like that. Now after a particular data has been achieved via the brain, okay, that if I'm touching a particular object, okay, for example, if I'm touching this particular pen, and if it's hot, then it can be either of two things. The brain can understand that you don't have to touch a pen. Okay, you don't have to touch a pen. Now that can be like the brain has got the information, it has got the data, but it came up to a wrong conclusion otherwise, and then it will stop touching pen until unless it touches something else and finds it hot as well. Okay, at that particular point of time, the brain will analyze that okay, from my past experiences, from the past data that I've achieved up till now, I've came up to this conclusion that whenever I'm touching a hot object, I'm getting burnt, and I shouldn't be touching any hot object. So this is how humans learn. Okay, now can we apply this idea of biological neural networks and this idea that I've already told you about how humans learn and apply that to machines as well? Of course, the answer is yes. That's why we are sitting here discussing this topic in this webinar. So, artificial neural networks as the mathematical model learning inspired by for learning for machines, inspired by the biological neural networks. So, I hope I'm clear up till this point of time. Okay, so if anyone has any problem or any queries, please do let me know, guys, so that I can help you guys out. I will give you 5 minutes. If you have any problems or any queries, please do let me know. Yes. So I hope everything up till this particular point of time is clear to every one of you, because this is very important, guys. You have to be on the same page with me so that you are also understanding what I am trying to tell you guys. Okay. Very important topics are being discussed right now. I hope that you are taking up notes as well, because that will also ensure that like you are retaining all this information even after this webinar as well. Of course, we'll be having many different webinars for you guys all throughout the year. Okay, and this is a small webinar. Okay, this is almost like 2 days long webinar. We are planning for a 6 day long, 7 day long webinars in the future. So please join the Telegram channel or join any WhatsApp groups for Shape AI and be a part of our community, and we will surely not be disappointing you. So moving further, okay, let's continue our discussion further as well. Okay, so yeah. So artificial neural networks, we'll be moving on from there. Artificial neural networks is a model mathematical function from that models the mathematical function from inputs to the outputs based on the structure and parameter of the network. So what is this? So we have got a particular output, okay, that I need two particular outputs, and I've got some particular inputs. Okay, so I will be using this particular architecture, all the parameters of the network to map these inputs to these outputs. Okay, we're mapping them so that if any input is given to us, we can achieve the output as well. So this is the idea behind the artificial neural network. Okay, it allows the learning of networks parameter based on data. So how much data that you provide, it will be learning from that. It will be learning the mapping from that particular data. It will be looking at the input data, trying to predict the output data. It will be checking if the output data is like almost similar or not. So I will be explaining you in a short, like we'll be of course discussing this in a lot of depth in the coming slides, but let's give a small intuition to what I'm saying right now. So think of it as in such a way. Okay, for example, you have been given some inputs and outputs. Okay, so this is the data. You have been given some inputs and the outputs. So what the artificial neural networks will do, it will take the inputs as an input. It will have some parameters, okay, called as weights. Okay, one dot 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 dot. So it will have some parameters. It will try to produce a complex mathematical function that tries to give us this particular some output O dash. Okay, so we get some output O dash. Now what the artificial neural network will do, will try to compute that if the output that was desired, that is the output given in the data originally, and the output that has come to you, okay, that you have got from this particular computation, how much difference is it between these two values? Okay, so if it's less, it is more. Okay, this is how the loss function is being made. Okay, now once you have got the, for example, how much difference, how much error is present, now using that particular error, you will then be like re-evaluating all these parameters. You will be increasing some of the parameters, you will be decreasing some of the parameters, so that the output, the mapping from the input to the output is as close as the desired output as possible. Okay, this is a small intuition about how the ANNs work. Of course, we'll be discussing this in much more depth in the coming in the coming slides, so you don't have to worry about it. So moving forward, so this is a biological neuron and this is a neuron or a unit, okay, that we have already discussed. So how are these two similar? Let's try to understand that. These neurons or the units can be connected to each other just like biological neurons are connected to each other. Okay, so for example, given some input, okay, x1 and x2 input attributes, you can predict if a person died or a person lived in a particular tragedy. For example, in the Titanic data set. Okay, so we will be dealing with this question in the coming videos. In the coming tomorrow's session, we'll be going hands on to answer this particular question about if I'm giving you some of the inputs. For example, if the person was male or female, if the person was like underage, for example, if it was below 18, or it was like a woman with an age of 24, whether that particular person was a first class passenger or a worker. So what is the possibility, what is the probability that that particular person would have survived or that particular person would have been killed? Okay, so we'll be answering this question in tomorrow's session. So let's take that particular example. In order to determine the hypothesis, this hypothesis function, okay, that is taking in some particular value, okay, taking in some particular attributes, we'll be putting it up in some hypothesis function of x1 comma x2, and then we'll be trying to predict if that person has lived, that is 1, or has died, that is 0. Okay, so this hypothesis function can be made in such a way. Here W0, W1, W2 are called as the weights. Okay, these are the parameters that we can adjust. X1 and X2 are the different input variables that has been provided to you. So these cannot be changed. This has been provided to you. Okay, and h of x1 comma x2 will give us the output. Okay, so determine and now we need to determine what these weights should be. Okay, we need to determine what these weights should be so that we can answer the question about what is the perfect hypothetical function that can be used to get the answer. Okay, so first let's discuss some of the activation functions. Now this particular function, so the x, okay, for example, the x can be 0 or 1, or the x can be like 400. So we need to find an h of x 1 comma x2. Sometimes, for example, in the case of the predicting the probability that a particular person has lived or died, so it's either 1 or 0. In that particular case, you'll have the output. Desired output would be a single digit, that is 1 or 0. Okay, in the case of predicting house prices, for example, you are working for Oyo, okay, not for Oyo, like redmagicbricks.com or something like that, and you need to predict what is the price of a particular house in a particular locality. I've been given the locality, I've been given the many different attributes has been given to you. So in that particular case, you will have to have your value in a particular number, for example, $14K or something like that. Okay, so this is something that can be varied. So in order to do that, what we'll be doing is we'll be enclosing the output from this particular hypothesis function in a particular function, another function called as the activation function. So how does this activation function work? So as you've already seen, we have been taking h of x1 comma x2 as the input to the activation function. Okay, so activation function, first type of activation function is the step function. As you can see, this is the particular step function. If it is not clear from the diagram, yeah, just increase the size of the, I hope this is clear to everyone that this particular thing is the step function. Okay, so what is a step function? At the end of the day, we need to do some classification, binary classification. For example, will he die or will he live, or is it a cat or is it not, or is it not a cat? Okay, or something like that. So these are all binary classification where you have two classes in which you need to classify the given input. So in this particular thing, we use step functions as the activation functions. So the h of x1 comma x2, okay, whatever the value is, okay, if it is greater than 0, okay, then we put like, okay, 1, that okay, that person will live, or if it is less than 0, then we put that that person dies. Okay, as this is the input to the activation function. So any value w dot x, okay, as you can see here, w dot x, if it is positive, then the then the output would be 1. If it is negative, then the output would be 0. So this is also called a step function. This is a very simple function. I hope you are able to understand this basic mathematics and nothing else. It's just addition, multiplication and all those things up till this particular point. This is something that even a 6th standard student should be able to understand. Moving forward to another function called a sigmoid function. Now sometimes you don't want the answer to be either, okay, if he has lived, okay, that is 1, or if he or she has died. Sometimes you want the answer to be a probability. Okay, so the probability of survival is 0.66, that is 66%, or the probability of survival is 10%. Sometimes you want to have your answer in percentage. So at that particular point of time, you will use a sigmoid function. So whatever the input, that is f of h of x1 comma x2, so here h of x1 comma x2 is the x. So this is the sigmoid function, as you can see here, and this is how we'll be plotting a sigmoid function. So if h of x1 comma x2 is, for example, here, okay, so I can just put a particular dotted line, okay, perpendicular to this particular x-axis, and then again a dotted line perpendicular to the y-axis. This is the probability of that particular person that he or she has lived or died. So this is how activation function, sigmoid activation function works. Now another activation function is, for example, in some cases, we require the either we take the positive output. Okay, for example, we do not want a negative output. It may be the case with, for example, house prices. Okay, so the house prices cannot be below, it cannot be negative $500. It can always be positive 1,000, positive 220,000 or something like that. So in that particular case, we use ReLU. The function for ReLU is max of 0 comma x. Okay, so here x is again h of x1 comma x2. So if h of x1 comma x2 is less than 0, okay, that means between 0 and h1 comma x2, okay, always 0 would be the maximum, because h of x1 comma x2 is less than 0, that is negative. So below that particular point, below 0, it will always be 0, and above that it is always x, that is equivalent to h of x1 comma x2. So it will be a straight line from there. So this is a ReLU function. This is also a very important function, guys. In the recent years, this function has come into play a lot in all the different artificial neural networks that we are creating. So very important concept, guys. So this is how we will be seeing. So h of x1 comma x2, we will be replacing that with g of, that is the activation function, the phi. Okay, activation function. Okay, so this is the activation function, guys, and this is the input, the original h of x1 comma x2. Now we are replacing this h of x1 comma x2 with this entire formula. So this is the new activation function, can be thought of as another function that applies to the result of this particular computation. Okay, very easy concept to understand, guys. There's nothing new in here, just simple mathematics, and I hope you are able to understand all these concepts, because this is the foundational knowledge behind artificial neural networks. Of course, it is very difficult to understand, make you all understand all these in just 1 hour, 1.5 hours, but I'm trying my level best so that you are able to understand the core concepts behind an artificial neural network. Moving forward, so let's try to understand, like let's try to visually understand what exactly is happening. So x1 and x2 are our inputs. Okay, we are feeding our inputs in these neurons. Okay, so these are the x1 and the x2. These x1 and x2 then get multiplied with w1 and w2 to give us w1 x1 plus w2 x2. Here you can divide this particular neuron into two sets. The first set is a summation, okay, and the second set is the activation function. So what does this summation does? It gets three different outputs. Okay, the first input is x1 dot w1, the second is x2 dot w2, and the third is w naught. So it takes in all the three inputs that this particular neuron is getting, and it brings us this particular summation w naught plus w1 x1 plus w2 x2. Now the second part, okay, the second part, that is phi, that is the activation function g, will then be applying its activation function over the entire particular function, and this gives us the hypothesis function that we have already seen down here below. So this is how a particular neural network, a simple neural network works. Now let's try to understand this by a simple like example, that is the OR function. Now guys, whomsoever does not understand or does not know what an OR function is, please write it down in the live chat. If anyone has any questions or any doubts, I'll be answering it right now. So if you have any doubts or any questions, please let me know, and then we'll be continuing with the session. Okay, because there's a lot that we have to cover right now. This is very important, guys. Also, we will not be providing any type of recording to this particular session in any way. Okay, so if you're missing out this particular session, you're missing out on a lot of things. Okay, so for those who still have any questions, who are not able to understand anything, or those who don't understand or function, please do let me know so that I can handle them accordingly. Okay, if you don't understand what an OR function is, please guys do let me know. If you guys are not able to understand what an OR function is, please guys do let me know. Also in the meantime, for the others, please do subscribe us so that you guys stay updated with all the upcoming sessions. Okay, that in which we are going to have many different workshops all throughout the years on different topics, from web development to Android development to Flutter, data science, and many other things as well. Okay, so do subscribe us, guys, and till that particular time, I hope everyone is familiar with an OR function. If someone is not familiar with an OR function, please guys do let me know so that I can help you guys out accordingly. Okay, so let's get started, guys, with the upcoming like other things that we were already doing. Yeah. So just ignore this. Okay, this is something that has been wronged. Okay, just it's yeah, that's fine. So take an example of an OR function. So what is an OR function? It takes in two inputs, A and B, and it returns A or B. If A is 1 or B is 1, then the answer would be 1. So for example, A is 0 and B is 0, so the answer would be 0. If A is 0 and B is 1, then the answer would be 1 because B is 1. Okay, if A is 1, B is 0, the answer would be 1. Okay, because A is 1. If A is also 1 and B is also 1, the answer would always be 1. So this is how an OR function operates. Okay, so let's try to understand the OR function. Let's try to implement the OR function using this particular simple neural network. So here I've taken pre-computed, okay, I've pre-computed some of the weights. Okay, so the W naught, Yeah, so the W naught is -1, W1 is 1, and W2 is also 1. Okay, so I've pre-computed some of the values. I'll be taking X naught. So let's take 0 as the first input. Okay, so 0 comma 0 as the first input values. Now here we'll be replacing X. Okay, this is X1 and this is X2. Okay, so we'll be replacing X1 with a 0, be replacing X2 as well with a 0. Now computing this particular value, you will be getting -1. Very easy to understand, nothing new. So we'll be taking in the activation function as the step function. We will be taking in the activation function as the step function. So here the value of h of x1 comma x2 is -1. So -1 will be somewhere here, and hence the value of the activation would be 0. So it will be returning 0 as the output. So we already know in an OR function 0 comma 0 will give us 0 because none of the values are 1. Now let's take some other example. Okay, let's take some other example. Continuing with this particular thing. Yeah. So again, taking another example, this is 1, this is 2. Okay, this time we will take 1 and 0. Okay, very easy guys. Be replacing x1 by 1 and x2 by 0. Now computing this particular value, we get 0, and here 0, as we can see, has value 1. Okay, so we'll be getting 1 as the output. Very easy, nothing new. Okay, just like putting in the values, computing the h of x1 comma x2, putting it back into the activation layer and getting the output. It is very easy to understand and nothing new in this. Okay, so here I've like the same slides are done like in the form of slides. Okay, so of course this can be used in probability as well. So for example, classification. So I've given you the humidity of a particular day, I've given you the pressure at a particular day, and you will have to find the probability that it will rain. Okay, so very easy guys, that humidity and pressure has been given as the x1 and x2, and you are providing the output as the probability that it will rain. Okay, we can also use it for regression. For example, you are a part of Shape AI, and we want to figure out whether we are getting better sales, okay, for our data analyst training and internship program via our advertisements or via our webinar. Okay, so for example, this is a particular webinar where I pitch you my particular product. For example, we have a product called as Data Analyst Internship and Training Program. This is a 4-month long program in which we teach you everything from data structures to competitive programming to data analysis process, from basic of Python to advanced like how to make websites, how to put your data onto those, how to put your visualizations there. We connect you with companies so that you can go and get placed. Our first batch has just graduated, and we are proud to announce that almost 22 of the 30 students that we had in our first batch have got into companies like Microsoft, Goldman Sachs, GE, DE Shaw, and many other companies as well. You can check it out on our website, shapeai.tech. So for example, from this particular webinar, I get 5 particular sales, and from my advertisement, I get 100 sales. Okay, and of course, like I am spending like $1 lakh dollars. Okay, on my advertisements, and I'm spending about $500 on my webinars. So what are the net sales that I can achieve, okay, in the future? This is a regression statement. So this is also something that you will need to understand. Okay, so now moving on, like we have already figured out, this is a very simple neural network. Okay, 2 input neurons and 1 output neurons. But what about complex neural networks? These simple neural networks cannot, they cannot showcase the output as XOR. So what happened was these neural networks, when it was found in 1950s and 1960s, it became hugely popular. Okay, like it was the next big thing in the entire world. People were thinking like now artificial intelligence, like real conversational robots were very like near and all those things. But it was far from truth. What happened exactly was when they tried, okay, to implement these simple neurons for XOR. Okay, I hope you are familiar with the XOR. Just like OR is XOR, and it failed badly. Okay, so people lost all their interest in this particular topic. They moved forward. They started with the support vector machines, okay, linear regression, multiple linear regression, and all these other architectures, other mathematical formulations that came into being for machine learning, and people started losing their interest in neural networks. And this was a winter. This is considered the period from the 1950s to 1990s is considered as a winter in neural networks. Okay, so knowledge winter. So after 1990s, what happened was people started connecting neurons together. So instead of connecting just two input neurons or single output neurons, what they did was they had a particular input neuron, they had a particular hidden layer, okay, a single layer of multiple neurons, and then an output layer. So this is the input, this is the output, and this is the hidden layers. So what happened was they started connecting these dots, okay, these input layers, okay, and then it started connecting with the output as well. Okay, this is how the complex neural networks came into being. Okay, and these neural networks were easily able to handle the XOR data as well. But the problem with these so this particular neural network that came into being, the first greatest implementation of this particular neural network was handwritten digits. Okay, so there were 28 by 28 pixel wide images of handwritten digits. So they were able to use this particular architecture. Okay, this particular layer of hidden layers had 512 neurons present. Okay, this particular input layer had 28 into 28 neurons present, and this output layer had 10 neurons present from 0 to 9 to classify it accordingly. So in that particular case, this was the first implementation of this architecture, and this was done by banks. Okay, so taking your checks in and digitalizing the particular checks is where this particular neural network called as LeNet, okay, LENET, came into being and was hugely popular. But again, a period from 1980s to 19 to early 2000s saw winter in like the development for these neural networks. So what was the problem? The problem was our architecture, our hardware was not so like well built so that it can handle all these computations. It couldn't able to handle all these computations really well, because these are huge matrices and you are taking the transpose of the matrices. Those who are familiar with a little bit of coding, so any transpose of a matrice takes to the power 3 on a normal scale. So that was a huge deal at that particular point of time. And slowly and steadily, like we came with all these NVIDIA graphic cards. Like currently, you have 2016 your laptops. You have the 30 like the series coming up soon in your desktops as well. So these all like graphical units were so powerful that you were able. There was a boost in the like making of these neural networks, and thus came the deep neural networks. This is an extension to the complex neural networks itself, in which you have an hidden input layer, you have an output layer, okay, and in the middle you have different hidden layers. There are multiple hidden layers, not a single hidden layer, guys. You have multiple hidden layers that are present. Okay, now what this ensures is having multiple so these early, so this is called as the input layer, okay, this is called as the output layer, these are called as the bottom layers. Okay, These are called as bottom layers, and these are called as the top layers. Okay, so this is how multiple hidden layers came into being. Each of these hidden layers are also well connected to each other. Okay, that is dense. Each neuron in the hidden layer is connected to all the neurons in the preceding hidden layer. Now this is called as dense connection. Okay, this is called as dense connections, and this is very important, guys. This will be something that we'll be practically dealing with tomorrow. Okay, so having multiple hidden layers ensures that you are able to get as many features, as many possible combination of features that you can get and produce optimal outputs. Okay, so this is deep neural networks. Moving forward, now these deep neural networks are also referred to as feed forward neural networks. Why feed forward? Okay, so neural networks have connections that only propagate in one direction. Okay, it's not that the input from one neuron is then being propagated back again to some other neuron in the early stages. The output, like the if we are taking an input, we're giving the output to this particular hidden layer, then to this particular hidden layer, and so on and so forth. So the input is taken in, it gives some output that is passed on to the network. The network then propagates the input and output, and then we get an output. So this is also called as feed forward neural network. We also have some other recurrent neural networks that are called as RNN, which is an advanced topic. And surely, if you are joining us for the training session, we will be dealing with it in a lot of detail. Okay, so now we need to understand one thing, that is loss function. Now you are giving us a particular output. Okay, let's say y is your particular output. Okay, now we need to check if that the output that we are getting is optimal or not. Let's wait for 5 more minutes, guys. Let's try to take a 5 more minute break. If you have any questions or queries for me, please do let me know. Okay, so that I can handle those questions and queries. Okay, please, guys, do let me know if you have some questions or queries, so that I can handle them out. This is very important, guys. This is a session that is going to, like, if you are dealing with these topics individually, you will take at least 7 to 8 days to understand each of these topics. It's a huge topic that we are discussing, and this is very important to understand the project tomorrow. Otherwise, you won't be able to get any flair of that particular project. Okay, very important, guys. Try to understand all these concepts. Okay, of course, like I've already said, those people who want to join us, you can go onto our chat. Like if you are on your laptops, you can go onto our website, shapeai.tech. It's a good website. You can check out our people from there as well. Okay, shapeai.tech. So this is our website, guys. And above itself, you can see meet our batch one graduates and where they have been placed. So these graduates have just graduated this particular month. As you can see, Shubham Kumar has been placed in Goldman Sachs. Sahil Garg has been placed in Nutanix. Harshit Mittal in Sourcefuge. We have other people as well. Pranjal Kumar, Microsoft. Ajit Garg, Wells Fargo. Abhay Patro also as well, Fargo. Avinish Kumar in Goldman Sachs, Raghav Loya in Walmart, Atulya Arya in Goldman Sachs again, Abhishek Sahai in Microsoft, Devesh Vishwakarma in Reliance, Mahi Patel in Dutch Bank, and so on and so forth. There are many other people we need to update this particular list. More than 22 people have got successfully placed as a software development intern or a particular like a business data analyst intern in these companies. Also, one of the best thing about them is the average salary, that like average package for the internship that has been offered is 60,000 per month. One of the people that is Ashish Modi has, like, we have taken that particular person in as an intern in Shape AI. He's working on a package of 40,000 per month as an intern as well. We also have two people who have got placed in a foreign MNC, one in, I guess, a French MNC, and the other one in a US based MNC as well, with an average package of like about, I think so, it was about like 70 to 80,000 rupees per month as a stipend for the internship. So we deliver performance, we deliver what we are trying to say upon. So if you are joining us for the data analyst training and internship program, please look into the entire website. The syllabus and everything is available. We will be dealing with data structures and algorithms, competitive programming, the entire machine learning, deep learning as well. So let's move forward, guys. Let's move forward with the loss function. Let's try to understand all these concepts in a lot depth as well. Okay, so let's move forward. So let's start, guys. So loss function. So loss function is a function that quantifies how happy or unhappy you would be if you have used W, that are the weights, that is W. So what is W? W is the, like, you can think of as that an array of W naught, W1, W2, and so on and so forth. So W to make a particular prediction on X. So what is X is the inputs, and to get a particular output y, that is the outputs that you have got. Okay, so now we are taking y dash as the desired output. Okay, we'll be taking y dash as the desired output. So we have given you a particular X, you constructed a particular architecture. Okay, you use some of these W, that is the some of these weights, to get a particular output y. Now is that particular y like what you desired or not? That particular y is closer to the desired output or not? So for that we use this loss function. So what is this loss function? Let's try to understand that right now. So a loss function, okay, so we have a predicted value y dash is equals to f of x. Okay, y dash is a f of x, and y is the particular value that you have you can think of y as f of x is equals to phi of h of x1 comma x2. Okay, this is the predicted value that you got from the neural network. Okay, neural network value. Okay, and this is the desired value. Okay, y is the desired value that, like, you get from the data set. Okay, you get this values usually provided. If it's provided, there is a supervised learning. If it's not provided, it's an unsupervised learning. So it is let's think of it as now has been provided in the data. So what we'll be doing is we can find this loss function in three different ways. First of all, we can directly subtract, that is the desired output minus y dash. So this is the loss function, simple and straightforward. What is the difference between what we wanted and what we have got? Okay, so this is a loss function. The second loss function that we can implement is y minus y dash the whole square. Okay, and the third one is y minus y dash. We are taking the absolute value for that. So let's discuss this in a little bit detail. So y minus y dash, the simple y minus y dash, is called as residual loss. So why will we be using this? So this is used, so this is simple, guys. We have got a desired value y, and we need to find the difference between the predicted value and the desired value to find the loss. Okay, now why this is not used anywhere? So for example, for some of the loss, for example, for one particular predicted value, you have predicted something that is greater than that particular value, and for another predicted value, you have predicted something that is very smaller than particular value. So when I compute the minus, when I do subtraction, so this would be negative and this would be positive. Now when I'm computing the loss, so what would be the loss? This would be the sum of these losses, individual losses. Now this will evaluate to 0. That there is no loss, your function is working absolutely fine and you're doing great. But this is not the case. You can see that the predicted values are not like, so this is the y dash and this is the y. So the predicted value are not even close to what we actually desired. So in that particular case, you get 0 as the output. So this is why like residual loss got changed via the squared loss and the absolute loss. Okay, so what is squared loss? What the squared loss does is whatever the value was inside, okay, it just squares that particular value. So when we are squaring a particular value, what this ensures is even if the inside value was negative or was positive, it will always, the output would always be positive. Similarly here, whether the value inside value was negative or positive, the outside value would always be positive. So this is why we use squared loss and absolute loss a lot. Now to choose in between these losses. So which would we be choosing? So for that we will be discussing. This is a huge topic, guys, and cannot be covered in such a small part of time. But I hope you are able to understand what are the different types of losses and why we do not use residual loss but squared loss and absolute loss. Very easy, guys, very easy to understand. Again, I'm trying to explain that this particular live session would not be available after this session has ended. This is a live session itself. It will be available for the next 30 minutes or so, then it will be taken down. Okay, moving forward, W1 versus W2 plot. So as you have already seen this particular loss, okay, so what I can write this particular loss as y of y minus phi of, here phi is the activation function of w naught plus w1 x1 plus w2 x2. Okay, so as you can see here, this, and we can take the whole square or the absolute value depending upon what we need. So this is the loss. Now as you can see, these values w not w1 w2, these are the only values that I can change. Okay, these are the parameters, so these are called as the parameters, and these are all the values that can be changed. X1 x2 are fixed because those are the inputs. Y is fixed because that is the desired output that is being given in the data. Okay, the activation function itself is fixed because you're choosing an activation function. So the only thing that you can change to like manipulate to increase or decrease the loss is w0, w1 and w2. So let's plot this w0, w1, w2. So let's take a plot of w1 versus w2. So very simple, guys. So this particular plot, as you can see, would look something like this. So let's take a smaller pen right here. I guess there's no good pen. Okay, so this will look something like, so for each value, okay, for each value of w1 or w2, we'll get a particular point of a loss. Okay, so let's, like, this is w1, this is the w2. Okay, and we are plotting these. Okay, so this will be like a, so look something like this. Now you will be thinking like, oh, Shaurya, so what you have drawn here, I'm not able to understand anything. Okay, what exactly is this? Like, this looks like some rings inside some rings inside some rings. So this is a canonical function. Okay, this is a canonical graph. If I'm plotting it in like a proper graph, in a two-dimensional graph, it will look somewhat like this. Looks somewhat like this. Okay, so as you can see down here, it is a 3D graph. Okay, you can understand this as a 3D graph with the minima at here. So you can understand it as a bowl. Okay, think of it as a bowl. Okay, so this is the W1, this is the W2, this is the loss. Okay, so think of it as a bowl structure. Okay, as you're going, you need to minimize the loss. to get the best output, that is your output is closest to your particular desired output, so you need to get the loss to this particular minima. Okay, this is where the loss is at its minimum value. So for doing that, you will be adjusting, you need to find these particular values of w1 and w2. So for that, if I'm like just pushing it back up and creating another particular, as you can see here, I guess, if I'm pushing it back up, you will be able to see that I can create a particular graph of, so this is w1 comma w2, like different values of w1 comma w2, and I will be able to, and this is the loss. So if I'm pushing it back up, I'll be getting a particular loss function like this. Okay, so this is called as the, like, the slope. Okay, so now if at any point of time, like for those who have already studied this, I hope that you have paid attention into your 11th and 12th mathematics, you will know that to find the minima of any function like this, what you need to do. If any one of you knows how to find the minima of this particular function, please do write it down in the comment section. Okay, so we have this particular function, okay, this particular function, this parabolic function, and we need to find the minima of this particular function. So how will we be finding it? So you might have remembered that, okay, we can just compute the partial differentiation of loss, okay, with respect to w1 w2, and equate it to 0 to get this particular point. Okay, and when we are getting this particular point, we'll be able to get w1 and w2 as well, and then we can easily get our predictions very easily. So this is where gradient descent comes in. What we try to do is we take initialize a spot anywhere, random spot on this particular slope, and then we try to find the slope. Okay, we take small steps, go down, we take, okay, just change the color. Yeah, we initialize ourselves right here, we take a small step, we go down below, we take a small step, we go down below, we take a small step, go down below, we take a small step, go down below, and which each step what we are doing is we are first computing the loss. Okay, if we are moving in the right direction or not. Okay, we are moving in the right direction, we take one more step, then one more step, then one more step, until and unless we have reached our minima. Okay, this is how the gradient descent works. Now, of course, we'll be dealing with all these mathematical functions in a lot of depth in the data analyst training and internship program, which you can check out on our website shapeai.tech. The entire syllabus and everything is posted there. We'll be covering entire mathematics, be covering with entire implementation of these algorithms, be dealing with PyTorch, TensorFlow, Seaborn, and many other things. Please do let us see it and let us know your feedback if you want to join. The first batch is starting from the 1st of November, guys. Okay, the first batch will start from the 1st of November. So those who want to join, please do hurry, because I think so there are only 10 seats remaining right now. So please look into it, and it will be great for you to join us, because I've already shown you that we show results and nothing else. So moving forward, so this is where we'll be ending today's session. Okay, I've given you a small intuition behind all the different things that are available in this particular session that is called as artificial neural networks. Tomorrow we'll be dealing with the more advanced concepts behind all these things. Okay, it will be amazing for all of you to join us tomorrow as well. I hope you are a part of any of the Shape AI WhatsApp group or the Telegram channel. The link to the Telegram channel is in the description of this particular video. Okay, you can join us from there as well. If you have any doubts, any queries, I am available on all the WhatsApp groups as well. You can contact me anytime and I will be happy to help you out. Okay, do check out our course on shapeai.tech. It's an amazing course, guys. We guarantee that you get into a good company if you are following through us, and of course you will be taught by mentors from Microsoft and Geo as well. Okay, so the data analyst training and internship program, it's a 4 month long program. Okay, as you can see, the cost is also not that much. That is like almost like 750 rupees per month. And you can see the syllabus as well. We will be covering a lot from like data structures and algorithms to competitive coding to monthly hackathons, open source event. Of course, like I've already said, Ashish Modi from our first batch has joined us as a machine learning engineer intern at Shape AI with a stipend of about 40,000 rupees. Our maximum stipend has went up till 1.2 lakh rupees per month in Goldman Sachs to almost, I guess, 4 people. So that's also a great thing. So mock interviews, we'll preparing you for interview preparation, that is technical as well as non-technical, that is HR interviews. After the completion of the training, and we'll be treating it as an internship as well. There will be a lot of projects, hands-on projects, huge projects that you can put up on your resume. After the completion of the training, we'll be providing you with a 4 month long internship certificate as a data analyst or a software engineer, depending upon your capabilities, and also a letter of recommendation for working as an intern at Shape AI as well. Okay, so this is a huge thing. We'll be covering everything, guys. Do check it out. ShapeAI.tech is our website. Look at our graduates and be the next one in line. And we can promise you, if you are joining us, it will be worth your time. Okay, you will never regret it. The next time you're speaking to anyone, you'll be taking it. Joining Shape AI was the best decision of your life. So let's hope that you will be coming to the tomorrow's session as well. There are limited seats available, guys, for the data analyst training and internship program. Just 10 seats available, guys. So because all the seats have been booked up till now. So if you're joining us, do let us know. You can contact me anytime if you have any doubts or issues or anything. Okay, so let's meet tomorrow, guys, for the hands-on project. Okay, that is the Titanic dataset. The same timings will be taken up by Parag Mittal from Microsoft. He's another instructor here at Shape AI. So it was an amazing time, guys, with you. I hope just be a little more like interactive. Okay, try to write down things in the chat section so to make this session more interactive. So let's meet tomorrow, guys, and hope you have a good day ahead. Thank you.